In this video, I'm going to talk about the structs and how to make method for each struct. A structure or a struct is a custom type which defined by a programmer. The struct stores a collection of different fields into a single field. They are useful for grouping data together. To create a struct, we need to use type keyword name of the struct, the struct keyword, opening and closing curly brackets. In a struct body, we can define a field such as name or age, whatever we want to have it here, and in front of them we need to define the type of the field. So for the name we need a string, and for the age we need integer. So this is how we define a struct in Golang. To assign a value to the struct, we have three ways to do it. The basic way of assigning the variable to the struct is to use the struct name and open and close the brackets, and then we can put the field like so. And also notice that the colon is added here and the comma at the end. So the next will be the age, and also at the end we need to have the comma, otherwise we're going to get complaint from the compiler. So now we can get the result. As you can see, the values that we assign to this struct is going to print out. So the second way of doing this is to assign to a variable and use that variable, use dot to access the fields, the name of the field equal, and then the value for other fields as well. If you run this, you're going to see the result as the output. And the third way of doing this is to have the struct, open and close the curly brackets, and then do the same, adding the values. So let's run this. As you can see, we can get the result. Struct tags are actually meta information for a struct field. The struct tag used in various packages to give more information or data about field. At the end of the line, we can use backtick and then the tag name. So for example, JSON, and colon double quote the meta information that we're going to assign to this field, and then closing it and closing the backtick. Same for the other field. So the JSON is used to deserialize the receiving JSON file. So for example, if the keyword of this name in the JSON file is username, but you don't want to change this field to username actually, so we can have the name because maybe it's nicer for our code, but this is what we receive on the JSON, and we want to convert this to this name. So we can use the username or the different naming on the JSON we receive, and the JSON package will take care of this. So another usage of having a tag can be the validation. So here is how we define multiple tags for one field. So we're starting with the tag file, colon, double quote, and then for the second tag we need to use a space here, and then we do the same thing. And here how we define tags and multiple tags for each field. Since the struct is the custom type that defined by a programmer and store different fields with different types, we can have a nested struct too, because the struct also is another type. What I mean is we can have address, and this address is going to have a location type, and we're going to define the location type here. This is actually a nested struct, because if we don't want to have this out, we can have it this way, right? But this is very messy and it's not going to be really practical. So we do the location, and then we define a location struct, and also we can have a geolocation, and it's going to have another struct type which we're going to define it here, geostruct, like so. And also we can have a contact information. So we're going to have a contact info type, and we're going to make the contact info struct here. So benefit of the nested structs is that we can organize our code, looks a little bit nicer. We can encapsulate related data and behavior. It allows us to build a complex data structure, and also to create the hierarchy namespace for the data. For example, if we want to get the person geolocation latitude data here, we can say p dot address dot geolocation dot latitude. So this is going to give us only the latitude, so we haven't defined, so we shouldn't get anything. We should get 0, as we can see. In Go, we can define an anonymous struct for those data structure that has a short lifespan, and we're not going to use it for the entire program. But for this example, we can use var person, the variable, how we define a variable usually, and then equal to struct keyword, and then the field, and closing the curly bracket. But then after that, we need to open the curly bracket and assign some value, and now we can print this and see the result. Here we go. Now we can also have anonymous field in a struct. That means we don't define any keyword for the field. It's going to be only the type. For example, here is the status type. So the status struct is referring to HTTP status or the response status. So it's going to be the string, and the second field is going to be the integer. In this, we can have status, and then the first field is a string, and then the second field will be the status code, and here we can see the result. The other thing is that we can have fields with keyword and anonymous fields. So the first two here is anonymous, and then the third we can have with the keyword, which is the detail, and this is going to be the string. So in this we can use detail. So if you run it, we get the full data of this struct. In Golang, we can create method for the struct. It sounds like an object or object-oriented, but let's don't name it anything for now. Go supports some of the object-oriented programming features, but not all. For example, first is encapsulation. Encapsulating data but doesn't have inheritance like C++, for example. Second is abstraction, focusing on essential characteristics and behavior while hiding the unnecessary details. Third is a polymorphism, allows objects of different type to be treated as objects of a common base type. And the fourth is composition, allowing objects to be built by combining similar objects. In Go, struct type and methods are defined separately. Methods are associated with some struct type, but not defined inside the struct type, unlike classes in object-oriented programming languages. Don't worry if it sounds complicated. Later in future videos, you will see them in practice. Now let's make some methods. Methods are like functions, but they have an extra part, which is the receiver. So if we want to create the method for message struct, we need to use func keyword and then parentheses as a receiver. Inside that, we're going to have the variable and then the type, which is message, and then the name of the method, which is broadcast. If we want to have some parameters, we can do it like functions. So in this example, we have for loop, and then we're going to send message text to client IDs. This is how we create a method for the struct. And now let's say we have a main function that is going to have hub1, and then we're going to have message from the message struct. So now, since the message is defined with the message type, we're going to have the broadcast method for this. And that's how we create the method for a struct and how we can use it. And also I want to add one more thing, that the method can also return some values. If not sent to any of the clients, return false. If all good, return true. We can have send to all clients. So if we run it now, we can get the result as true. That was all for this video, and thanks for watching.